Can you hear me? Good afternoon, everybody. Today I'll start with a new module of complex analysis. So far, we have learned how to make differentiation of complex function, and with that we learned what is Cauchy-Riemann equation. Using Cauchy-Riemann equation, how we can find the complex harmonic conjugate using either Cauchy-Riemann equation or Milne-Thomson method. So this part I think you are clear, and if there is any question or any, just to bring the, just wait, I also use the same link in my mobile. Just to bring now I am skipping one module which is complex integration. That is a little difficult. Before that, I will complete the conformal mapping, which is very much useful, as well as it is simple also. It is easy to solve the problem in this module. So mapping is nothing but a function. A function always maps some points in one domain to some other points in a different domain. In single variable function, we write y equal to fx. That means give any point in the x domain, it will be mapped somewhere in the y domain, right? Generally, the point input x and the value y is mapped in a two-dimensional plane. It can be described by a curve or straight line or anything. And for complex function, you have learned that some region, there is no scope. There is no scope to describe any complex function by a curve. Instead, we generally give some region in Z domain, and the image is again described by some other region in W domain. Both are complex, both are two-dimensional. Here, conformal mapping. What is a conformal mapping? In a map, through a mapping, suppose one curve, every points on a curve in Z plane is mapped to some other points, a set of points in W plane. Practically, both will be curve. Curve means one may be straight line, another may be an ellipse or circle, something maybe. But if you map every point of a curve in the Z plane, it will be mapped to some other curve. It will be mapped to some other curve in W plane. Now, if I consider two intersecting curves in Z plane, then those two curves will be mapped to two different curves in W plane. Suppose their intersecting point means one point is common to them. So what about with the common to that curve? you consider, say z0 is the intersecting point, z0 is the intersecting point of the two curves. If go through the figure, it will be easier. Suppose C1 here, C1 is a curve, this one, and C2 is a curve, this one. This is intersecting at this point P. Now, if suppose this curve is mapped to here C1 dash and the curve C2 is mapped to C2 dash. There is a common point here. After the mapping, the image of this point, say P dash, will lie on C1 dash. Again, it has a common to this point is common is on the C2 also, though. So the image of this point will also lie on the curve C dash 2. That means the image will be common to the two curves. Now at this point, suppose I draw a tangent to the curve C1 and draw another tangent to the curve C2, and I want to find what is the angle between these two. That will be called the angle between two curves. Angle between two curves means at a particular point of intersection, we draw the tangent to the two curves, and the angle between these two tangents is known as the angle between the two curves. And conformal mapping means before mapping these are the curves C1 and C2, and this is the angle. Angle is shown by here. This is the gradient of this curve, this theta 1 say, and this is the gradient of this second curve, you can say theta 2. The difference is this one. This is the angle between the two curves here in Z plane. Now consider the image C1 dash and C2 dash. Here also we will find similar angle. If both the angle here, this is the tangent to C2 dash and this is the tangent to C1 dash. The angle between these two is theta. Theta means it could be different, but if the angle between the curve in Z plane and the angle between the image curves in the W plane remains same, then it is called conformal. The meaning of conformal is angle preserving mapping. Angle preserving, right? Conformal mapping means this mapping preserves the angle between any two curves, means any two curves in the Z plane and between their images in the W plane. So this is the definition. Before that I can go through it. Only one condition is required. As you know, first of all, the function must be analytic. When it is possible, when it preserves angle. First of all, the curve must be analytic. Analytic means Cauchy-Riemann equation will be satisfied. Means you can, instead of fz, you can write uxy plus ivxy. You can take the partial derivatives with respect to x and y of both u and v. Then those derivatives should be continuous and should satisfy the Cauchy-Riemann equation. Then we will say it is analytic function. And along with that, one additional condition is there. F dash z means derivative of that function will never be zero. Never be zero means where it is angle preserving, where it is conformal, at that point it cannot be zero. And if it is zero, then at that point it is not conformal. In other points it may be zero, it may be conformal. So this is there are a lot of example will come to some of them. So w equal to z to the power n, where n is some integer, it is conformal mapping. W equal to, you can check it, w equal to sin z or w equal to cos z or w equal to z plus some square by z means some positive number by z is also conformal mapping, right? With conformal mapping, you have some utilization in electrical engineering. Generally, if I consider current, generally we first consider potential, right? If the potential difference between 2 points is there, not zero, then there will be a flow from first point to the second point, right? And in space where is some charges are kept, we can consider that around that charges there will be some surface where on each point of that surface the potential is same, means there will be no flow along that surface, and the current will always flow perpendicular that surface. Earlier also we talked about it. Generally harmonic conjugates, what we have found, if some function equal to constant represents equipotential surface, then v equal to constant we represent some line of flow of current which is also perpendicular to that surface. And because of that property only, we given one thing we can find out the other one. If I know the flow of current, the equation of the line of flow of currents, then we can find out the equipotential surface, and if we know the equipotential surfaces, then we can find out the flow of line of flow of currents. So conformal mapping, why it is useful? Conformal mapping means always we transform one domain to another domain. You know, here I will show you how the domains are getting changed. First of all, what is conformal mapping? It is a mapping which preserves angle, right? That means at a point z0 in its domain, it preserves angle between two originating curves, as it is shown here. The mapping is such that suppose f is a mapping where some region of means some domain in z plane is mapped into some codomain in w plane. In z plane our coordinate axes are x and y. In w plane our coordinate axes are u and v, right? So every point is mapped to some other points here. So a curve will be mapped to some other curves here. Similarly, C1 and C2, both the curves will be mapped to C1 dash and C2 dash shape. The shape may be changed, some straight line may be curved, some curve may be straight line, may be the possibility. But if there is any point of intersection between any two curves in this plane, in this region, then the angle between the images of those two curves will be same. That is the condition of conformal mapping. And for that, what to check whether a mapping is conformal or not? First of all, you have to check whether it is analytic or not. If it is analytic, then check whether the function derivative of that function is 0 or not. If it is 0 at some point, not that the function derivative of function is everywhere 0, that means it is a constant function, right? If it is 0 for some values of z, those values of z, those points will be called the critical points of the mapping. Means at that point the function is not conformal. So how to find it? Critical points, you take the derivatives of the equation f dash z. If w equal to f z is a mapping, consider the derivative of f z, that means f dash z, you equate to 0, find at what value the function, what value of z, the derivative vanishes. Clear? These will be called critical points of a conformal mapping. Some other points are there which won't be shift, right? If I write say w equal to 5z, and we consider the whole complex plane is mapped to some other w plane. See, if I consider the point 0, 0, with z equal to 0 plus I0 and w equal to some 5 into k, 5 into z, what will be the value? 5 into 0 plus I into 5 into 0. So 0 will be mapped to 0 only. There is no change in coordinates after the mapping. These type of points are called invariant point or fixed point. Means even after the mapping, those points will not be changed. They will remain in the same position. See, there are two types of points. One is critical points where the mapping is not conformal. That means where f dash z equal to 0, and there may be some points, not always, both are not always. It may happen. There may be some points where the points which won't change even after mapping. Those points will be called either fixed point or invariant points. Clear? Now we talked about invariant points. Now take the example. Suppose w equal to z cube. Its derivative will be w equal to f z equal to z cube. So f dash z is 3z square. Where it is 0? Z square. When z is 0, so z equal to 0 is a critical point, because f dash z is 0 at the point z equal to 0. Now what are invariant points? If I write the z after mapping, it will become w, not w, it will become z only. So I can write z equal to z cube, because after mapping z will be z cube, but it will remain same as z. So I can write z equal to z cube. So z cube minus z equal to 0, that means z into z square minus 1 equal to 0. What are the possible values? Z equal to 0, z equal to plus 1, z equal to minus 1. So these 3 points after mapping will not change. These are the invariant points or fixed points of the mapping. Clear? Now consider a simple mapping. How it is? W equal to z plus some constant. This constant may be real or may be complex number. If it is complex number, I can write a equal to, a is a constant, it may be complex constant. That means it may have two components, say a1 plus I a2. Clear? After the mapping, what will happen? Take any point z which is x plus iy, right? And for that, you consider the image as w equal to u plus iv. Now comparing real and imaginary part, what we will have? U equal to x plus a1 and v equal to y plus a2. Clear? So I will get, after comparing real and imaginary part, we will get the relationship u equal to x plus a1 and v equal to y plus a2. Now you see, it has been seen that function this shift every point z through a distance a1 in x direction, means every point you will be same as x plus some constant. So every point has been shifted to a1 distance. Similarly, every point will be shifted by A2 distance in the vertical direction. Clear? And in other words, each point W, each point Z is shifted by a distance modulus A, which is equal to square root of a point is moving in the x direction by A1 and in y direction by A2. So what is the angular distance? Means actual displacement is square root of A1 square plus A2 square, which is nothing but modulus of A, modulus of this. So in this mapping, every point will be shifted through a distance modulus A. This type of transformation or mapping is called a translation, because here every point will be translated through a distance A modulus A in the same direction. Here is a printing mistakes. I think it will be 3.2. I have taken this from my own book and modified it. That's why. And in this document your module is 3, but in the book it was chapter 18. That's why there is a conflict. So I will change it to 3.2. Here again I have to do one thing. I am just giving you another image. Just wait for 1 minute. That figure is missing. I am just giving you some handwritten figure so that you can follow it. I have sent you figure 3.2. I have just sent you. You just go through it. Just okay. I am again. Now you see on the left hand side, that is z plane. In the z plane, there is a point P whose coordinate is x comma I y, or in complex form I can write x plus iy. And after mapping, what will happen? The new coordinate, see, consider, now look at the w plane. First you write down what is a1 plus I a2. So a1 plus I a2, you consider that point, and along with that, now your coordinate w, the x coordinate of w is x plus a1. So with a1 you add x. Similarly with a2 you add y for y coordinate of the image p dash. Now the coordinate of p dash is w plus a. That means what is happening? This point origin has been shifted, or the point has been shifted a amount, modulus a amount, in the direction of OP, not OP. So OA you can say, where OA means the point small a, complex number small a, whose coordinates is a1, a2. So the point P has been shifted by the modulus a in the direction of complex number OA. That's why, since every point will be shifted, even origin will be shifted to A. If I write z equal to 0, that will be origin, and after the mapping, the 0 will reach at the point A1, I, A2. Since every point has been shifted under this mapping is called a translation. Generally, for any kind of transformation, a mapping is nothing but a transformation. You are transforming one object to another object, another one area to another area. There are totally three type of transformation possible. One is just shifting in a particular direction. Another is multiplying, magnification, not shifting, something like looking through a lens. Small object will be either bigger or smaller. That will be a magnification. And third is rotation. Instead of just shifting, you can rotate something. Suppose one ellipse, one parabola was there with right side opening. You rotate it to 90 degree. It will be a parabola with upper side opening. So there are three type of main possibility. Another possibility is there, which is called inversion, means in mirror image or something like that. So first of all, we are considering translation. Translation, for any translation, the form will be w equal to z plus some constant. The constant in general be complex number. It may be real number also, because if the complex part is 0, then it is real. It will be shifted in the horizon, in the x direction only. Now another conformal mapping is w equal to some constant. This constant is real, some constant into z. We are talking about magnification or contraction. Means multiplication and division are similar. If I multiply with a fraction, then it is nothing but division. So here magnification means not that always it will be bigger. It may be smaller also. You are magnifying with some number. If the number is more than 1, then it is really magnification. If the k is less than 1, if k is greater than 1, it is a magnification. If k is less than 1, it is contraction. Actually the image will be smaller one. So if I consider this mapping w equal to kz, where k is a real number. It does not have complex part. That's why k greater than 0. With complex number we cannot write. A complex number greater than 0 or less than 0, it does not have any meaning. Clear? Here, if I write in similar way, say u equal w equal to u plus iv, z equal to x plus iy, then I separate real and imaginary part. What will happen? X equal u equal to kx, y equal to v equal to ky. Then another thing is, that means every coordinate, everything has been multiplied. X is multiplied by k amount and y is multiplied by k amount. If I express this in other form, suppose k equal to z, z means modulus of z. If x plus iy is the number, then z is square root of x square plus y square. We can write any complex number in this polar form. This is the radial distance modulus z, and e to the power I theta, where theta is the argument of the complex number. Means if p is the complex number, o is origin, op. If OP makes an angle theta with the positive direction of x-axis, then theta, the complex number, can be expressed as modulus z into e to the power I theta. Right. Now, w equal to kz. That means w equal to k into e to the modulus z into e to the power I theta. So, the magnitude of w is k into magnitude of z, and argument of w is same as argument of z. Both will be theta. That means every length in the x plane, z plane, has been multiplied by a number k in the w plane. Thus, it can be observed that under this mapping, every point in the z plane is moved radically to a new position k into modulus z unit away from the origin. Now it is nearer or farther. It depends on the value of k. If k is 1, the distance is remaining same, there is no change. K is 1 means you are considering the mapping w equal to z. If k is more than 1, then definitely kz is more than z. That means it is moving away from the origin. And if k is less than 1, it is moving towards the origin. Consider any two points z0 and z1. Right. The distance, this will modulus z1 minus z0 will give the distance between these 2 points in the z plane. In the w plane, what will be the distance? It is kz1 minus kz0 modulus. So k, I can take out k into this part. So every segment in z plane will be multiplied, will be either magnified or contracted with the fraction with the number k. There is also same mistake. The image will be 3.3, instead of it has become 18.24. It was 18.23, I think, 19. Now consider, suppose these two are points. What we are talking about? Suppose one line segment is there which joins the points z0 and z1. Right. Then this is the line segment, and this length will be modulus z1 minus z0. After mapping, as I told you, that z0 will be shifted by from the original distance of the image of z0 will be kz0. So if k is more than 1, it will be somewhere like this. Similarly, Z1 will be moved by distance k Z1. So total length will be something like this. Now you join it. In that case, this distance is k times this length. It's k times modulus Z1 minus Z0. Right. So one thing you clear, if k is less than if k is less than 1, then this W0 will be somewhere here between 0 and this. Similarly, W1 will be somewhere here. Again, I can draw a parallel line. So, if k greater than 1, the distance between the image point will be increased or stretched, as well as the line segment will be shifted away from the origin. So the line segment has been shifted away from the origin. This is the original here, and this is actually the image in the W plane, right? If k greater than 1, the line segment has been shifted away from the origin and its length is k times of the original length. If it is less than 1, the line segment will be shifted nearer to the origin and it will be contracted. This type of mapping is called a magnification. Magnification means generally mean it has been magnified, mean enlarged. But in mathematics, if it is more than 1, it is enlarged. If it is less than 1, it is a contraction, but it is enlarged by a fractional number. So under this mapping, if I map a circle here, suppose one circle was there, under this mapping what will happen? It will remain a circle. Only thing is its center is also will be shifted somewhere, either this side or this side from the original center. Either it will be on the line joining the original center towards the origin or away from the origin, depending on the value of k. Circle will remain a circle, its center will be shifted and radius will be either enlarged or decreased. So these are the two basic types of mapping. I will consider another one. Today I am starting this one. It is a this mapping is a little elaborate. The first two one were very simple. You have to remember it. The second one, you just try to remember the end result, how it looks. Not that all the theory you have to understand clearly. Still, I am discussing here. Suppose another mapping is say W equal to e to the power z. So W equal to, I can write W equal to e to the power x plus iy. In place of z, I have written x plus iy in terms of two components. That means what will be the modulus W? Modulus of W, actually this number can be written as e to the power x within bracket cos y plus I sin y. So modulus W is modulus of e to the power x into modulus of cos x plus I sin cos y plus I sin y. What is the modulus of cos y plus I sin y? It is square root of cos square y plus sin square y. Cos square y plus sin square y is 1. So it is 1. So modulus of W is actually e to the power x. There is no need of modulus here because e to the power x is always positive. For minus infinity it is 0, for plus infinity infinite. So it is always positive. So there is no requirement for keeping modulus here. So modulus of W under this mapping, the modulus of original modulus was x. Sorry, modulus of this mapping, the modulus of z was square root of x square plus y square, and modulus of W is becoming e to the power real part of z, right? And what about argument of W? Argument of W is argument of this one. So what is its real part? Its real part is e to the power x cos y, and imaginary part is e to the power x sin y. If I write y by, so v by u, here not y, just like if I write imaginary part, here it is v, means sin e to the power x sin y, and, and real part is e to the power x cos y. You take the ratio, e to the power x will cancel out, you will get tan y. So argument is tan inverse v by u. So tan inverse tan y, that means y, and this is principal argument may be y. With principal argument we can add anything, 2 pi into any integer, positive, negative, right? So your general argument will be 2n pi plus y. Clear? So under this mapping, your modulus of this w, function w, is e to the power x, e to the power real part of z, and argument is 2n pi plus imaginary part of z. 2n pi, if I consider 2n pi you have taken because it is a general and it is not principal. Again, y may not be the principal argument because all it depends on whether y lies between minus pi and plus pi. It should be minus pi less than y less than equal to pi. It cannot be equal to minus pi. It should be more than minus pi and less than equal to pi. In that range, y should be. Suppose y is say 15. It is not lying that. So you have to subtract 2n pi. 2n pi means maybe 2 pi, 3 pi, 4 pi. Sorry, not 2 pi, 2 pi. 2 pi, 4 pi, 6 pi, even multiple of pi. 2n pi means n into 2 pi. So you subtract 2 pi. Try to make it, keep it in the range minus pi to 2 pi. If it is still more outside that, again you subtract. Suppose y is negative, say negative 3, pi is how much? 3 point something. So you take, suppose y is minus 4. So minus 4, here if I write general argument this one, so that means 2n pi minus 4. Principal, what will be the principal argument? It cannot be minus 4. With minus 4 you have to add 2 pi. 2 pi minus 4, now it is in the range minus pi to 2 pi. So I cannot write the principal argument is y. It depends on the numerical value of y. If it is already in the range, then it is principal argument. If it is outside the range, you have to add or subtract even multiple of 2 pi, integer multiple of 2 pi, so as to bring it within that range. Now under this mapping, point x0 or y0, now consider this one. Suppose one line segment is there, it is horizontal line segment, means on this line segment the y coordinate is fixed, it is y0, there is no change, only x is changing. X is changing from x0 to x1. For this line segment, what will be the image here? That first we will consider a horizontal line segment where y is always fixed, it is y0, and x is changing between x0 to x1. Now consider the first point, starting point P. At the point P, the value of y is y0 and value of x is x0. So as per your modulus is e to the power x0. The point is, so modulus of that image w0 is e to the power x0, because this is, there it is x, so it will be x0, and argument is this one. Argument is, if I consider at this moment, say it is principal argument and it is within the range. Here we are assuming that it is within that range minus pi to pi. Y0 is within that range. Then your principal argument is y0. Now consider the second point. Which one? This point P, sorry, Q. For Q, the coordinate is x1 and y0. x1 plus I y0. So as per this one, again your modulus means, suppose image is w1. So modulus of w1 is e to the power x1, and argument of w1, since it depends on y only, so it will be y0 again. That means these points is moved, rotated. This point, the image has been rotated by an angle. Rotated by an angle y0, and modulus of first point is e to the power x0, and modulus of second point is e to the power x1. Both are not same. That's why the image will be like this. Both has been shifted. It was horizontal, right? It was horizontal. Now depending on y0, this length, it has been rotated to an angle. If the angle lies between minus pi to plus pi, then either it will minus pi mean up to this, and sorry, plus pi means up to this line, and minus pi means this way, but it should not reach that line, just below that minus pi. And in this direction, if I count, it will be plus pi. So it depends on the value. So after the mapping, each point is rotated to an angle y0, and if p distance modulus is, what is modulus? Modulus of a complex number means it gives the distance of that point from the origin. So the image, the distance of the image p dash from the origin is e to the power x0, and the distance of the image q dash from the origin is e to the power x1. So this distance, originally the distance was x1 minus x0. Now the distance is e to the power x1 minus e to the power x0. So it has been depending on the value of x1 y1, x0 x1, this length will vary. It is a power of e to the power of e. That's why it will not be same as x1 minus x0. Now, so every line segment here will be a line segment in w plane, but it has been rotated through an angle y0. What is that y0? This is the distance of the horizontal line from the x-axis, and the length of this image will be e to the power x0 minus e to the power x1. Clear? If I consider vertical line segment, something like this one, what is the criteria here? Here the horizontal distance is same for both the points P and Q. X coordinate is x0 and y coordinate, here it is y1, y0, here it is y1. Now, so we are considering one line segment. On the line segment, for every point x equal to x0 and y is changing between y0 minus y1. As before, at the point P, this is the point, we put it and we see that the modulus is e to the power x0 and argument is y0. Now go to the point Q, this part is same, so modulus is same. That means in the image, the distance of P and Q are remaining same. The distance of P and Q are remaining same, but the angle argument for the first point it is y0, for the second point it is y1. So the distance will be something like that. Image of P and Q will be such that their distance from the origin are same. It is e to the power x0. But the argument of OP, the angle OP makes with the axis U is y0 and the angle made by the line OQ dash, O dash Q dash with the U axis is y1. Definitely we have written y0 less than y1. That means this angle will be more. So, and all points in between lies between everywhere the same criteria. The distance will be same, the angle will be something different. Instead of angle y1 or y0, it will be somewhere in between. So the angle is changing this way. So this point OP dash, OQ dash are same. If I take some other point R, it will be somewhere here. So the distance of the line, image of distance of the points on the image of this line will be same, constant. All will be e to the power x0 and the angle will be different. That's why, so if you consider everything, you will consider the whole line segment, it will be an arc of a circle with center at origin and the radius is e to the power x0, x0 is this one, e to the power x0 is the radius of this circle and this arc, how much arc, it depends on y0 and y1. Suppose y0 and y1 is 2 pi plus y0. This distance is 2 pi and y1 is y0 plus 2 pi. In that case, it will rotate through a full 2 pi angle. If it is less than that, we will find some part of this circle, not full. If it is more than 2 pi, it will rotate, it will complete one rotation, then again it will move somewhere. It may move twice, thrice, depending on the difference between y0 and y1. Clear? So, under the mapping, y equal to w equal to e to the power z, a horizontal line will be mapped to another line which will be rotated to an angle y, y0. What is y0? Y0 is the y coordinates of every point on that horizontal line. But a vertical line will be transformed to an arc of a circle whose radius is e to the power x0. x0 is for every point on that line segment, x0 is the x coordinate or real part, and it will form an arc of the circle here with center at the origin. These two property, you further timing, you remember it. It will be helpful to understand some problem, but most of the problems are simple, will simply skip. Here it is explained. if y equal to 2 pi plus y0, means y0 and y1 such that the difference is equal to 2 pi. In that case, the circle will be traversed once. If it is more than 2 pi, then the circle will be traversed more than once. If it is less than 2 pi, then only a part of the arc of the circle will be created. Now, if I take the consider instead of one line, we can consider a horizontal strip like this. It is infinite, right? Up to minus infinity to this, and it is above the x-axis, infinite strip, and say 0 to this, it is going towards infinity. In that case, what will happen? Now, as I told you, your modulus was e to the power x0 everywhere. First, the horizontal line. First, we consider the horizontal line, this one. As before, so in the horizontal line, here x is varies from minus infinity to 0. Clear? So minus infinity to 0. That means your modulus, what will be the modulus? Here the line segment, not this side, it is coming from minus, p is at minus infinity and q at 0. So p image of p will be e to the power minus infinity. What is that? E to the power minus infinity is practically 0. That means this p at infinity will map to 0 in the w plane. Clear? And q is on the y-axis. Q is on the y-axis. That means q is 0. For q, x is 0. In that case, OQ is e to the power 0 means 1. So, it will be 0 to 1 somewhere here. So, P dash will be here and Q will be somewhere here where the length is 1. Clear? So, every line will be rotated somewhere, and the segment will be 0 to 1 unit type. P dash will be always at the origin and Q dash will be along a line segment which makes angle y0 with the u-axis, and p dash q dash or oq dash is 1 unit. Now take another line. What we have mapped so far? The line on the x-axis which start at minus infinity and ends at 0. If I consider any other line, strip, we are considering this strip. You consider any other point y0 here, any point. In that case, the distance will not be, it will start from not 0. Depending on y0, rotation is because of y0, and for x coordinates we are getting the length. This length is coming from x0 and x1, and the rotation is coming from the y coordinate. At the point 0, the rotation is 0, rotation is 1. Sorry, at the point 0, when on this line y is 0, that means rotation, there is no rotation, it is along this line will be mapped to the line here, 0 to this. If I consider any other y0, same line, x is changing from minus infinity to plus infinity, so the length of the image will be 1 unit starting from 0 to some other point here. Now consider y0, it will make some angle y0 here. So image of this line will be this one. So if I go on mapping this, it will be some part of this. All depends on what is the value of y1. If it is less than y 2 pi, then it will be a part of this circle means actually including the inside. You are rotating one line 0 to 1 towards 0 to y1 angle. The total angle is y1. Take any line parallel to x-axis. Take any line which is y0 distance away from the x-axis. It will be mapped somewhere here or somewhere here. And if it is equal to pi, it will just this strip. So 0 to 2 pi, 0 to 2 pi, say y equal to 2 pi here. If I consider this strip, it will map to a full circle with center at the origin, radius 1. If it is less than 2 pi, it will be a part of the circle, not that only arc, including the internal space. It will be bounded by these two radius, this one and corresponding to this one, which corresponds to this imaginary part y1, this angle. Clear? So under this mapping, a horizontal strip from minus infinity to up to x-axis will be mapped to a unit circle or part of it. If this y1 is more than 2 pi, it will be repeated somewhere after completion. If it is 2 pi, it will be a complete circle. If it is more than 2 pi, it will traverse once, then again retraverse. Okay, this is for the next one, mapping properties of log z. Today I will stop here, because if you want to follow, then first you have to go through the second one, math 2b complex E 5 to 9. This part is a little difficult, you have to study 5 to 7, right? Then, and this one is just the reverse, means under this mapping log z, this one will be mapped to this type of thing. So if this is the domain in your z plane, and this will be your image on the w plane, just the inverse. Okay, let us stop here. I have given you some solution to that principal values of related problem. You go through it. If someone want to check your answer sheet, I can call you right now. If you are present, I can discuss your problem, right? So I am closing here. After this, if somebody is there, want to check your answer sheet, I can call you immediately right now. Okay. Okay, thank you very much for joining this class, and wish you all the best.